All right, welcome to the last section of Unit 7, Section 7.5, Cramer's Rule. So Cramer's Rule is a alternative way to solve for variables if you have a system of two equations, so x and y, or if you have three equations, three variables, x, y, and z. Focuses on using determinants, so we'll show you the ins and outs of that today. For most of this, you can use your calculator. So it goes by pretty quick. So we'll go ahead and get started. All right, so basically here's what Cramer's rule tells me. To find, if I have a 2 by 2 matrix, I can find the variable x by doing the determinant of the matrix dx over d. And I'll explain what that is on the next slide. And we can find y by doing dy, or the determinant of dy, over the determinant of d. And again, we'll see exactly what that means on the next slide. So here's a system of two equations, two variables. You can see they both have x and y and what they're equal to. To set up our three matrices, D is just the coefficients of x and y. So 4, -2, 3, -5. As you see them in the equation, that's matrix D. Dx, we replace the x coefficients with what the equations equal. So instead of 4 and 3, we replaced them with 10 and 11. And I color-coded that so you can see that. And for dy, we keep the 4 and 3, and we replace the y coefficients with what the equations equal, with 10 and 11. So that's how we get d, dx, and dy. D is the coefficients as they appear in your original equation. Dx, you replace the x coefficients with what the equations equal. And dy, you replace the y coefficients with what the equations equal. And so that's how we get these three matrices. And then it's just a matter of finding the determinant to get your x and y values. So again, here's d, dx, dy from the previous slide. And to do the determinant, we just cross multiply and subtract. So the determinant of d is -14. dx, -50, plus 22 is -28. And 44 minus 30 is 14. So now we have d, dx, dy. And to get x and y, we just divide. So dx over d, x is 2, dy over d, y is -1, and here's our ordered pair, 2, -1 to finish it out. So again, you take your determinants for 2 by 2s. Those are quick enough to do by hand. I wouldn't enter those in the calculator, but when we get into a 3 by 3, for sure we would enter those in the calculator and crunch out the determinant that way, rather than doing minors and cofactors 3 times. All right, so here's another example. And again, you can see that here's my system of equations. So I have my x and y coefficients. For dx, I replace 3 and -7 with 46 and -6. And for dy, I replace 2 and 8 with 46 and -6. Again, we'll find our determinants, cross multiply. So 24 minus -14 is 38. 368 minus -12 or plus 12 is 380. And -18 minus -32, so plus 332 is 304. Again, once I have d, dx, and dy, I do dx divided by d, so 380 divided by 38 is 10, and 304 divided by 38 is 8. You can write it as ordered pair if you'd like. I didn't here. I'll go ahead and add that in since we're here. So 10, 8. But as long as you state what x and y equal, you're good. Okay, next slide. 3 by 3 matrices. You don't have to change colors. A lot of times you'll just see this will be written as 2x plus z equals 0. So I just put the 0y in there to hold our column values to make sure we don't mess that up. So you can see matrix D, I just took our coefficients from the three matrices, and that's D. For dx, I replace this first column with 1, 0, and 2. dy, replace the values in this middle column with 1, 0, and 2. And dz, we replace the third column with 1, 0, and 2. So you can see that right there. And again, at this point, you can crunch out these determinants by hand. I do not recommend that. I would go ahead and put them in your calculator and do the determinant of each that way. So the determinant of d is 10, dx is 8, dy is negative 15, and dz is 16. And then to get our values for each variable, then we just do dx over d, so 0.8, dy over d, which should be negative 1.50 there. Sorry about that. Okay, get a decimal point in there. Give me a second. There we go. And z is going to be 1.6. So again, find your determinants, you divide, and that is Cramer's rule. A couple more examples here, and then we'll be wrapped up for the day. Typically, we won't go more than 3 by 3 with Cramer's rule. Can you go into larger matrices? You can, but that's really not necessary. All right, test for collinear. So collinear means that all your points are on the same line. And so the way we test that with the matrix, we'll take our 3 points here, and you see we've got x1, y1, x2, y2, x3, y3. That's just showing that we have 3 distinct different points. We'll throw them into a matrix, x coordinate, y coordinate, then the second point, third point, and we'll make our third column all 1s. And what we'll do is we take the determinant of this, and if the determinant equals 0, then they're collinear. If the determinant equals any other number, then they are not collinear, which means one or more of the points are not on the same line. All right, so here's 3 points, 2, 3, 3, 5, and 5, 9. We make the last column all 1s. And then we go ahead and take the determinant of this. It does equal 0. And since the determinant of this matrix is 0, that tells us that all of the points are collinear. So again, if they ask you to do this, determine if 3 points are collinear, put them into a matrix, make the last column 1, and then take the determinant of that. If it equals 0, you have points on the same line, collinear. If it equals any other number, positive or negative, then they are not on the same line. We can also do a similar deal to find the area of a triangle. So if you know the 3 vertices of a triangle, we can use this formula here. So we put our 3 points in a matrix, same way that we would for collinear. So first point, second point, third point, make the third column all 1s. You take the determinant of that matrix and you multiply by positive or negative 1/2. And the way you determine that, you want your final answer, your area, to be positive. So if your determinant is negative, multiply by negative 1/2. If your determinant is positive, multiply by positive 1/2. Whatever one you need so that your final answer is positive, and that will give you the area of a triangle. So especially if you have a non-right triangle and you don't have a way to find the altitude, you can take the 3 points, plug them in a matrix, do determinant, multiply by 1/2, and you're there. So let's take a look. So here's a triangle. There are 3 vertices, negative 7, 8, negative 2, 5, and 12, 10. Make that last column all 1s. I take the determinant of this matrix. It's 257. Since that's a positive, I'm going to multiply by positive 1/2. And the area of this particular triangle is 128.5 units squared. If they give you the units, feet or inches or meters, label accordingly. Otherwise, just units squared. And you can write UN squared. You don't have to spell out units. That's fine. So again, they give you the 3 vertices of a triangle, throw them in a matrix, truthfully, it doesn't even matter which order. If you want to put this one first and this one, you could do that. Doesn't matter. Just make sure that third column's all ones. You take the determinant of this matrix and then multiply it by positive or negative 1/2 so that you get a positive answer at the end. All right, number 11, last one here. So you can see we have a rectangle, and they gave us the 4 vertices for the rectangle, and then we also have a triangle here. And our directive is to find the area of the rectangle or inside the rectangle if we cut out the triangle. So if we cut this piece out, we want to know the area of all of this outside of the triangle. All right, so area of a rectangle, we know how to do that. If we went, you can see here that the y values are the same. So from -8 to 12, that's a length of 20. And here the x's are the same. So from 2 to 8 is a length of 8. So we have a rectangle that's 20 by 8 for an area of 160. Our triangle, we're going to use the method that we just learned. So we've got our 3 vertices. Again, it doesn't matter which one you put first here, so I just went this way. But 1, 9, -5, 6, 8, 4. Make that third column all ones. Took my determinant and got 51. So half of that is 25.5. And again, we want the area of the rectangle if the triangle was cut out of it. So we're going to take this area minus this one. And our final answer is 134.5 units squared. So that wraps up 7.5 with Cramer's rule and also finding collinear points in area of a triangle. As always, you got any questions, hit me up with an email or invite for Google Hangouts and we'll help you out. All right, thanks.